Welcome to a video that's going to look at some more examples of the distributive property. Okay, so first of all, let's just do a very simple example to remind ourselves what the distributive property is. Here we have parentheses with two terms inside and a number on the outside. So to distribute means to multiply everything by that number on the outside. So doing it very slowly, we're going to take -3 and multiply it times 4x. And then to that, we're going to do -3 times, and I'm thinking of this right here as a -1. And these are adding, but since it's negative, we can think of that as subtracting. Subtraction and negatives kind of go back and forth a lot. Okay, so -3 times 4x would be -12x, because -3 times 4 is -12, and then the x is going to multiply 2, but it can't really multiply by the number, so we just write it as -12x. And remember, you don't have to put a dot, you can just write -12x. That implies multiplication. All right, next we have a -3 times a -1. Since a negative times a negative is a positive, this is going to change back to addition. And 3 times 1 is just 3. And that's it. That's all we can do. We're just simplifying the expression. Second example. Write 9y minus 2 divided by 11 as a sum or difference. Well, what they're wanting you to do is write it as one term plus another term if it's a sum, or one term subtracting minus another term, without this dividing stuff at the denominator. Okay, so that's our goal. All right, so one way that we can do that is we can sort of think of this like distribution. Instead of dividing by 11, we can think of it like we're multiplying by 1 over 11 times 9y minus 2. And it's kind of like we're distributing. So what I just wrote is equivalent to this. So that if we distribute, that would be 9y over 11 minus 2 over 11. And that is because when we multiply fractions, we multiply the top to the top and the bottom to the bottom. Since these are whole numbers, we can put this over 1. So 1 times 9y is 9y. 11 times 1 is 11. 1 times this minus 2 is minus 2. 11 times 1 is 11. You can also just think of it like you are dividing each part by the 11 instead of dividing both of them all together as by the 11. All right, number 3. Here we're distributing a negative sign. So this right here is what we're distributing. Well, not all of that, just this part. And you can think of it like multiplying times -1 if you'd like. What distributing a negative does is it changes the signs of the things in the inside, the terms. So here we have a negative times a -2z. That's going to cancel and give us a positive 2z, because a negative times a negative is a positive. And then we have a negative times a -5y, which is going to give you also a positive 5y. That's it. We don't have to write this plus in the front of the 2z though. You can just say 2z plus 5y. In fact, that looks a little neater. All right, number 4. Bushels of apples cost $7.95 at a farmer's market. How much would 8 bushels of apples cost? Use mental math. So here's the strategy they want you to do. $7.95 is very close to $8, right? But the difference is 5 cents. So instead of thinking of it as $7.95, think of it as $8 minus 5 cents. So if we write it like that, instead of doing $7.95 times 8 bushels, which is a little bit harder to do, we're changing it to 8 minus 0.05 times the 8. Now we distribute. 8 times 8 is $64. 8 times 5 cents is 40 cents. So then think about taking $64 and subtracting 40 cents. You would have $63.60. That is a lot easier than maybe using traditional methods to multiply 8 times the 7, then the 9 and the 5 and all that, and carrying and all that. Okay, last one. Let's practice combining like terms. Remember, like terms have the same combination of variables to the same power. So here we have an n squared. We have 5 n squareds. And we're subtracting 3 n squareds. So really what we're doing is we're doing 5 minus 3, which is 2 n squareds. And there's your answer. Notice the n squared does not change. All right, next, let's find our like terms here. We have a b and another b, so those are like terms. We have an 8, that's a constant term, and another constant term we have is a -4. Those are like terms. And then we have the c. There are no other c's, so there's nothing to combine with that. So we have b's, constants, and c's. So just go one at a time. Let's just go with b's. It doesn't matter which one. So really I'm doing 3 plus 6, which is 9b. Usually constant terms go at the end, so I'm going to do the c's next. So -2c didn't have anybody to combine to, so I'm just going to copy it. So I've got that one, and that one, and now I need the constants. So just what's 8 minus 4? It's 4. And there's your answer. Okay, and C, part C, is just the same idea, just more complicated. So be very careful to pay attention to the like terms, so the combination of variables. So we have a squared b to the 5th. I want you to think of that as one whole thing. Do I have another a squared b to the 5th? Well, here this is a to the 5th b squared, not the same thing. So I'm going to highlight that in a different color. Next we have a to the 5th b squared. Okay, so that's green, just like this one, because they're the same combination. So I can combine, I can combine these. -3 plus 7 is essentially what I'm combining. -3 plus 7 is 4. And then just copy the a to the 5th b squared. That doesn't change at all. Okay, but then we also have this other term. It didn't go anywhere, it just didn't combine anything. So I can put it in the front or behind, it doesn't matter. So 5a squared b to the 5th, and these are adding because the 4 is positive. Okay, there you go, all done.